right, so today we're talking about the fundamental counting principle, okay? These type of questions that we're about to look at, you've seen before, you know how to do it, you just might not know or recognize that the way you solve them is using the fundamental counting principle. So your notes are going to look a little tiny bit different than mine just because of the layout on the sheet of paper versus a PowerPoint, but they are the exact same thing, right? So what is the fundamental counting principle? This is at the top of your notes, okay? The fundamental counting principle allows us to count the number of ways a task can occur given a series of events.
Like the bonus.
Okay? Kind of like the bonus, but we're not really talking about the bonus today. We can talk about it more tomorrow, especially because we have someone in here who hasn't taken it yet. So,
Wait, so he's going to get the bonus.
no, we're not learning how to solve it today. Okay? So what this means is we're going to take the possibility of each task and we're going to multiply them together. All right? So look at the first example on your sheet. Okay? If we want to talk about the number of different possibilities for the lunch special, okay, you can get one sandwich, one soup, one dessert, and one drink. Just dessert.
I like dressing.
Okay? Every...
Dessert that goes on your sandwich.
There you go. So what I mean by different possibilities, different arrangements, if just one thing is different, that's a different arrangement, okay? Excuse me. So if I do chicken salad, tomato soup, a cookie, and tea, that's different than chicken salad, tomato soup, cookie, and Coke, all right? So figure out first how many possibilities there are in each category. How many sandwiches are there? How many soups are there? Go ahead and write that out next to each row. All right? So we've got 4 sandwiches, 3 soups, 2 desserts, and 5 drinks. What do you think we're going to do in order to find the total number of possibilities? Multiply them. 4 times 3 times 2 times 5, and what do you get when you do that? 120. Because if I were to write out a list, okay, if I were to pair chicken salad and tomato soup and cookies with all of these, then I would have 5 different possibilities. Well, that's going to happen 4 different times, and then I can switch it 3 times and 2 times. So if you were to sit there and write out a list, this is essentially what you would be doing. But I don't really want to write 120 things out, so I'd much rather use this counting principle. All right, next question. In how many ways can you answer a 5-question true or false test, assuming that you answer all of the questions? So don't yell it out. I want you to think about this for a moment. Okay? And the hint is think about how many answer choices there are for each question. Think about how many possible answer choices there are for each question. All right, ideas?
32.
Not quite 5 times 2. It's a little different. It's 2 to the 5th. Because in each answer blank, there's 2 options, right? In each answer blank, there's 2 options. So we're going to talk about, just like how we listed out the other options, the 4, the 3, the 2, the 3, there are 2 options in each of these blanks. 2 times 2 times 2 times 2 times 2, which we can also write as 2 to the 5th. Either way, what do you get as your answer? 32. Okay? I didn't show the hint. I just told you it. Okay? All right, now this isn't on your notes page, but let's talk about it. On that same test, 5 questions, true or false, what's the probability you will get 100 on the test? If you guess on every question. 1 out of 32. Because the probability that you get the right answer on each one is just 1/2 times 1/2 times 1/2 times 1/2 times 1/2.
That's without looking at the question, because then you have a...
Right. Just blind guessing, right? Yep. Okay. What is the probability you will get 100 on this test if there are 20 questions? Use your calculator. Figure it out. Hold on. Use your calculator and try it out.
Not very likely.
Wait, do you do half to the...
I don't think I did it right.
I don't know. 2 to the... Oh, there's cake right. I've been smelling that. I'm like, what's that?
All right, so what's the probability you will get 100 on this test? 1,048,576. So, how did we get that? Okay, what's your probability that you are right on each question? 1/2. How many questions are there? So we have 1/2 times 1/2 times 1/2, 20 times. So that's also 1/2 raised to the 20th power. Yes?
So for like an AP test, it would be like 1/5 times 120.
Yeah, if there were multiple choice, if you just guessed blindly, there were 5 answer choices each, then you would have 1/5 to whatever power that was. So, moral of the story, should you guess? No, you should study. You should study.
You're taking the SAT and you can reduce it to 3 chance choices. You should take.
Okay, but that's not what I'm talking about. All right?
Because there's a 1 point right there.
Okay. Here we go. A company places a 6-symbol code on each unit of product. The code consists of 4 digits, the first of which is the number 5. Those 4 digits are followed by 2 letters, the first of which is not a vowel. You have the answer or question?
Is Y a vowel?
No, Y is not a vowel. A-E-I-O-U. Okay? So, your hint, if I can find my cursor, your hint to get you started. Think about how many choices there are for each of the 6 spots in the code. There are 10 digits, there are 26 letters. How many of those 26 letters are vowels? 5 of those letters are vowels, so 21 consonants. It's a 6-digit code, so you have 6 spaces. All right, so take a second, try and think about this. There are 10 possible digits. The code is a 6-digit code. Just think about it for a minute. Aww. I didn't mean to give the answer. Okay. I know. We haven't gone over it yet. Hold on. Just hold on a minute. All right. So how many spots do we have in the code? 6. 1, 2, 3, 4, 5, 6. What has to go in the first digit? 5. 5 has to go there. So this is 5. What has to go in the next 3 spots? A digit. 0 through 9. So some digit. What has to go in the 5th spot? A consonant. Yeah, non-vowels. And what can go in the last spot? A letter. All right? So, how many options are there for the first spot? 1. How many options are there for the next spot?
10.
And the next one? And the next one? 0 through 9. There are 10 digits. How many possible options are there for the 5th spot? 21. And what about the last one? So what are we going to do with all of those numbers? We're going to multiply them. Okay, the counting principle tells us that we're going to multiply all the different possibilities. So when you multiply these together, what are you going to get?
546,000.
546,000. Questions? All right, let's look at the next one. So, well, first of all, let's talk about this for 1 second. 546,000 codes. If you are a really big company, would this be enough codes for you? No, if there was like a separate code, like a barcode on every single thing you produce, this wouldn't be enough, right? What could we do to up this number of possible codes? Yep, we could have more than 6 digits. That would be a possibility. What else could we do? We could leave the first one not 5, yeah. Yeah, we could make it letters or numbers. We could do, huh? You could use a different alphabet. Could we use lowercase and capitalized? Yeah, that would add more options. All right? So if you wanted to make a bigger code, we know that it would be more useful to choose letters. There's more to choose from, more options. Okay? All right. Let's look at number 4. I want you to try this one, please, on your own without talking. I want you to give this one a try. All right. How many options are there when you flip a quarter? How many options when you flip a dime? How many options when you flip or roll a 6-sided die? 6. 2 times 2 times 2 or times 6 is 24. Questions? All right. Let's go to number 5. Okay. Next semester, you're going to take 1 science class, 1 math class, 1 history class, and 1 English class. According to the schedule, you have 4 different science classes, 3 different math classes, 2 different history classes, and 3 different English classes to choose from. Assuming there's no scheduling conflicts, all of these can mix and match any way we want them to, would you please take a second and find out how many different 4-course selections you can make? Take a second, write it down, fill it out. What are the numbers we're going to multiply in this case? 4 times 3 times 2 times 3, and what should we get? 72. Good. Now, suppose that each of these, instead of different types of classes, each of these represented class periods. 4 class periods of science, 3 class periods of math, 2 class periods of history, and so on. What would be the probability that you would get your exact same schedule as, say, one of your best friends that you're hoping to get? 1 out of 72. There are 72 possible schedules. So your probability of getting the one you would want would be 1 out of 72. Okay? All right, let's talk about the next one. 6 students in a speech class all have to give their speech on the same day. One of the students insists on being first. If this student's request is granted, think about how many different ways there are to schedule the speeches. Now again, without calling out, I want you to try and work through this one. Think about writing out the 6 different spots and think about what could go in each spot. All right. How many possibilities are there for the first spot? 1, because that one really eager student is going in that first spot. How many possibilities are there after that one person goes to go second? 5. There are 5 options of people to go second. Once a student is picked to go second, how many options are there for who goes third? 4. And then fourth? Then then 1. So go ahead and multiply these all out, and what do we get? 120.
I don't understand when you use them.
When I use what?
Factorial.
We're gonna, okay.
This.
So what this is, okay, is if your options get 1 less each time. Okay? So, okay, so if say you 6 right here, Alex, Haley, Claire, Hannah, Sheila, and Josh, we're all standing about to get in line for the speeches. Okay? Once Haley is chosen to go first, how many people are left to go second? And then once Alex is chosen to go second, how many people are left to choose out of to go third?
Okay, I just don't see why it can't be the other way. Like, I get that, but, like, how do you know they're choosing one? And then, like,
Because if once you get that order set, that person is taken out of the mix. There's only 4 people now to choose from. Because there's one person that insists on going first. That one person is going first. After that one person goes, there's 5 people left. You're going to choose from those 5 people. Okay? It's kind of like the idea of when we're picking like the marbles out of the bag, right? The first time, if there's 6 red, after we pick one and don't replace it, how many are left in the bag? 5. So now we have to pick that one, and then there's only 4 left. So it's kind of like the without replacement idea, that once they're picked, they're out of the mix. Okay? Okay. So, what is it called when I multiply by each number 1 less? Yes, this is called a factorial. This 5 times 4 times 3 times 2 times 1. That is called a factorial. Okay? That is 5 factorial. It started with 5, then we multiplied by 4 times 3 times 2 times 1. And we write that as 5 exclamation point. That is how you write 5 factorial. Okay? Let's look at how you're going to put that in your calculator. Okay?
Wait, is that like an answer or something? Or?
It's kind of a shortcut. Instead of typing in 5 times 4 times 3 times 2 times 1, you can type in 5 factorial. So go ahead and press 5 on your calculator. All right, type in 5 on your calculator. Then go to Math. Arrow over to PRB. PRB stands for probability. If you arrow over to PRB and you look at number 4, you'll see that exclamation point. That is your factorial. So if we get 5 factorial, we can type in that exclamation point on my calculator and we'll get 120. Okay? Now, 5 times 4 times 3 times 2 times 1, that's not too bad to type in, right? We could really have done that. But what if there were 25 people in the class? Would we want to sit there and do 25 times 24 times 23 times 22 times 21? Would we want to do that? I wouldn't. Okay? Your calculator at some point, depending on whether you have a newer version or an old version, will hit an overflow. It can't find a factorial of everything. So what did you try, Catherine, that gave you an overflow? So 125 won't do. It does cut off at 69 for most of the models. Okay? 70 won't give you if you try 70, you'll get an overflow. But if you try 69 under that, you won't. Yes? It's that your calculator can't handle that much memory. Because look out, try like 20 factorial. Try that in your calculator. How big does that get? What's 20 factorial? How many places are there?
18.
Okay, it's times 10 to the 18th. That means after all those, that means you have to move that decimal point over 18 places. Okay? So 20 factorial is huge. It's times 10 to the 18th. Okay? So the bigger we get, our calculator just can't handle it. All right? Any other questions? All right, that's all I have for you. So your homework is on the back of that, so go ahead and flip that over.